important they are for a well-functioning of a soil, and we all know how important soil organic matter is for all these soil functions, because these are all soil-mediated ecosystem services. With regard to approach to question one, our approach was to identify ways how to improve soil organic carbon contents in soils. And of course, one is based on how can we add carbon, and the other one, how can we conserve the existing carbon in the soil. And regarding adding carbon, we only have two options. Either we use agricultural carbon sources or non-agricultural carbon sources. And with regard to conserving carbon, well, here we all know that we can reduce carbon mineralization, and this is extremely important, and this can only be achieved through adequate soil management. With regard to the second question, we additionally try to identify ways on how to enhance soil functionality and soil fertility, looking at physical, chemical, and biological aspects. Of course, what we found was the strong interlinkage between the soil functions and our capacity to improve the carbon status of our soils. Its contribution, as you can see here on the left, to soil aggregation and carbon sequestration. You see here the comparison between soil monolith on the right after 3 years of the application of conservation agriculture. You can see here the better aggregation on the one hand, and also already after 3 years only, the enrichment of the top with organic matter. We also know its contribution to and its role in providing nutrients to the crops grown. You see here the difference it makes with regard to the nitrogen input response of wheat yield if you have only 1 or 2% of soil organic matter. And of course, it's also extremely important to nurture soil biology. We discussed about the pros and cons of the application of organic amendments, such as slurry application here on the left, sewage sludge or biochar, which are all external inputs, thus transport and energy intensive, and with, of course, potential side effects. We also talked about and looked into the potential of proper soil management and mulching practices, both very much depending on minimum soil disturbance, because you cannot leave the soil covered if you dig around the soil. You only can leave the soil covered if you do only minimum soil disturbance. As equally important, we found the adequate selection of crops and or varieties to boost biomass input and diversity, as well as their consequent management to leave as much carbon as possible to feed the soil and the biota in there. According to the Brazilian saying, the grain for the man and the straw for the soil. Finally, another option was brought up was the use of microbial stimulants to enhance root growth, because we also know that root growth is introducing a lot of carbon into the soil and also in deeper layers. Then the group still reflected on some cross-cutting issues, such as the need for the definition of adequate indicators and reference values for soil organic carbon and soil quality, as there's still a lot of uncertainty about how much carbon we should envisage to achieve for each soil type and what increase in soil quality this would add. Another issue was the evergreen need of knowledge sharing and dissemination, especially about the contribution of soil organic matter to the soil's functions and the understanding of the role of soil biota. A strong concern that was also expressed was for the need of systems approaches and long-term evaluation to fully understand the soil's potential and role in mitigating climate change and contributing to it, adaptation to climate change. We still identified the needs for research and new technologies development efforts, which pursue to evaluate the economic benefits of soil organic matter improvement, because we hardly know what economic contribution higher soil organic matter contents bring. To select or breed crops for high biomass inputs, to also clearly evaluate the impacts of soil and crop management on soil biota and soil organic matter, evaluate the value of different plant residues for soil organic matter enhancement, and also to develop approaches to make low soil disturbance cropping systems less dependent on chemical weed control. And finally, to evaluate the long-term pros and cons of non-agricultural carbon sources. Finally, we put together a few projects and ideas worthwhile to be developed. One was on the assessment and recommendations for soil organic carbon management under given agroecological conditions. Another was on how to make the best use of the carbon sources produced in tree-based cropping systems to enhance soil organic matter. And another three projects proposed were based on the application of the principles of conservation agriculture, because there was a general agreement in the focus group that their application is a sine qua non condition to enhance soil organic matter in the most cost-effective way. So thanks for your attention.